Hi, so we're going to do the next unit. Next unit is all about oxidation states and half reactions and eventually moving on cells, batteries, and things like that. So first of all, we have to go through some rules. Assigning oxidation numbers. Here are your rules. You need to follow them. They're meant to be followed in order. They are in your packet, so you don't have to write all of this down. Some of them we know. Group 1 is always +1. Group 2 is always +2. Okay, those are the rules. Free elements, things that aren't bonded to anything, are 0. Otherwise, you need to look at this. If it's not on this list, go to your periodic table. So here's an example. It's binary. It's KCl. Okay, we're just going to look at that. And I walked through this. This is in your notes. KCl. First one, we're going to fill in the information. We have got a potassium, and there's one of them. A chlorine, there's one of them. I'm getting those ones from the subscripts, which aren't there, which means there's one. Next, we're going to fill in the oxidation state. Look at the rules above. Rules. Read number 1, read number 2, read number 3, read them in order. Okay, so potassium is +1, and I put a little information here as to why. Group 1 is always +1, has to be. Okay, and then chlorine, there's nothing in the rules, and then I go over to the periodic table, and there's a whole lot of oxidation states. I have no idea which one to use, so this is going to be X. Now we multiply down, subscript times oxidation state. 1 times 1 is 1. 1 times X is X. Number 4, we need to add to the total. In this case, since it's a compound, it's going to be 0. 1 plus X equals 0. Solve for X. Chlorine is -1. This one, not so bad. Pretty easy. They will get more complex as you go down because you're going to get into the polyatomics as well. Okay? Next part of your homework is half reactions. I love half reactions. So what you're going to do is you have a full reaction. We're going to take magnesium plus oxygen. We're going to get magnesium oxide. First thing we have to do is exactly what we were just doing. Find the oxidation states of every element there. So I did this for you. Magnesium is 0 because it's a free element. Oxygen is 0, free element. And then we get to magnesium oxide. Okay, it's a compound, which means we need to go through what we were just doing in our homework. Set up a matrix, that little table there. Now you might move beyond the table, but for the sake of the homework, you're going to use the table. And I find out that magnesium is a +2, oxygen's a -2, and then I'm going to put those numbers in here. Magnesium free element 0, oxygen 0, and I put my plus and -2 right in. Now I took that and I put it right at the top of the next page because I'm going through page by page here. Now all of this is in your notes or in your homework. You're going to break them apart. You're going to take that magnesium that goes to a magnesium and you're going to set them equal to each other. And you're going to leave those charges there. So you break them apart so that each has its own reaction. You're going to get rid of the coefficients. You're going to get rid of the phases. And any element that's on the same side or on both sides with the exact same charge, get rid of. They're spectators. We don't need them. We're only looking at the things that are changing. So magnesium 0 to magnesium +2, oxygen 0 to oxygen -2. Now we're going to take that and these are not balanced. I realize it's 1 to 1, but 0 for magnesium to a +2, can't have it. We can't get rid of matter. We can't even electrons. They just can't disappear. So we have to place the electrons. We're going to place them on the more positive side of each half reaction. Which means for letter A, magnesium 0 to magnesium +2. If the +2 is more positive than a 0, we're going to put electrons there. How many electrons? How much more positive is it? 0 to a +2 is difference of 2, so it's 2 electrons. Now, oxygen, 0, oxygen -2. 0 is a more positive number, so we're going to put the electrons on the 0 side. You always put 1 on the reactant and 1 on the product. And then you're going to identify. When you identify, you are going to, oh, and I forgot to change these subscripts and superscripts. Electrons are lost. Oxidation half reaction. They're lost. Reduction, electrons are gained. Leo goes grrr, and it's written out in your packet there. Lost electrons, oxidation. Leo goes gained electrons is reduction. Grrr. Okay, and there's an example there for you. Now, what does redox mean? Because I'm calling some things redox, some things oxidation reduction. Here it is. Redox. The red is reduction, ox is oxidation, and that is the basis for our entire unit. If you have questions, email me. Come to your conference. Otherwise, I will see you later.